Hello student, I am Sonali Kelkar from City International School and today we are going to study the chapter Chemical Reactions and Equation. This is the second part of the revision where I am taking all the reactions which are given in the chapter. Okay, now the last time where we stopped was combination reaction. Okay, so combination reaction where two or more reactants combines to form one product. In that we have done burning of coal, then we did respiration reaction. So respiration reaction was the last reaction, that is also a combination reaction, and what we found that combination reaction are exothermic reaction also, because in this reaction, in exothermic reaction, heat is evolved or heat is liberated. Now coming to the decomposition reaction. As we know, we have three types of decomposition reaction: thermal decomposition reaction, electric decomposition reaction, and photo decomposition reaction. We can also say thermolysis, electrolysis, and photolysis respectively. Now let's go through the reaction given in your book. So here is, in the decomposition reaction, the reactant is broken down into simpler product. Over here, AB is a reactant which is broken down into A and B. Clear? Simpler product. They can be a compound or they can be element. Now here comes the first reaction where this is an activity in your book where they have taken anhydrous iron sulfate. What do you mean by anhydrous? It means it has a quantity of water in it. Okay, so anhydrous iron sulfate is heated. Okay, then water will get evaporate and what is left is iron sulfate. And when you heat this iron sulfate, which is light green in color, when you heat this iron sulfate, you will get ferric oxide, which is white in color, and the two gases will be evolved, that is sulfur dioxide and sulfur trioxide. Right, now let's balance the equation. Over here iron is 1, here iron is 2. So if I write 2 here, now iron is 2 here, iron is 2. What about sulfur? 2, 1 and 2. Sulfur is 2 on the product side also. What about oxygen? 2 into 4, 8 atoms of oxygen. Over here 3 plus 2, 5, 6, 7, 8. So the equation is balanced, right? Coming to the next equation, CaCO3, which is nothing but limestone. Okay, now this reaction is very important reaction, and this particular process is this particular process is applied in cement industry.
Cement industry 40% चालू.
So next reaction in decomposition reaction is calcium carbonate, when heated, decomposed into calcium oxide and carbon dioxide. Right? What is calcium carbonate? This is limestone. When you heat, you will get quicklime. CaO is quicklime, and carbon dioxide gas is released. Right, carbon dioxide gas is released. Okay, right. This reaction is very important in cement industry. Cement manufacturer heat calcium carbonate to get CaO, which is a very important product in making cement. Okay, So let's see whether the equation is balanced or not. Calcium over here 1, 1. Carbon is 1 on the product side, here also 1, and oxygen is 3 over here. 1 plus 2, 3. So this is the balanced equation, right? The next reaction in decomposition reaction is when lead nitrate, okay, lead nitrate is a colorless solution. You have to take it in a test tube, heat lead nitrate, heat, apply heat, okay. So what you will get, a yellow solid of lead oxide and a brown gas fume of nitrogen dioxide will be released with oxygen. Clear? So let's balance the equation now. Lead over here 1 and 1, fine. And what about nitrogen? Nitrogen is 2 here, whereas nitrogen is 1 over here. Oxygen is 3 into 2, 6, whereas oxygen is 2 into 4. So let's start with the oxygen because oxygen has more number of atoms. So we see here 3 into 2, 6 over here, oxygen atoms. Over here 5, so I will write 2 over here, right? On the product side, now it is 2 oxygen, 2 plus 2, 4 plus 2, 6, clear? But what about lead? Now the lead over here is 2, so I have to write 2. So lead and oxygen is balanced. What is left over? Nitrogen. Nitrogen here. Now the nitrogen is, because the 2 is written in front of the nitrogen, so I will consider this 2 and 2 is over here, so I need to multiply this. So 2 into 2, the nitrogen atoms are 4 now. You cannot avoid this. This is written, that means this is for all this, all the element or all the atoms present in this. Clear? So 2 into 2, 4 nitrogen, right? Here only 1, so I will make it 4. Now the equation is balanced. So these all are the example of thermal decomposition, because all these compounds are decomposed, they are broken down into a simpler products with the help of heat. Now let's take the next decomposition, that is hydrolysis. Decomposition reaction, what we are going to do? We are going to pass electricity in water. So electrolysis, water, electricity, or electric current, you can write passed. So you will find the accumulation or the collection of two gases, that is hydrogen and oxygen, okay. And before we do this experiment, before we pass electric current to the water container, we have to add few drops of HCl or H2SO4, any acid, because when we mix these acid, the conduction of electricity will be faster, right? So when you add, suppose I am adding HCl, that HCl will get separated into ions. I will be getting hydrogen ion and calcium ion, H plus and hydrogen ion and chlorine ion, H plus and Cl negative. Because of the presence of ions in water, the conduction of electricity will improve. So this is the reason we add hydrochloric acid or H2SO4 in this solution. Clear? Now let's balance the equation. So here also we are using heat in a form of a current, which is going to decompose my reactant into simpler elements, right? So hydrogen here is 2, hydrogen is 2, but oxygen on the product side is single 1, so here 2. So let me make it 2. Okay, now hydrogen has chain, Here hydrogen is 4. 4 atom of hydrogen on reactant side. So I write 2 to balance the equation. Clear? Now these two are gases. You can write gas here and gas. Sorry. Fine. This is liquid. So this is about the decomposition reaction with the help of electric current. Next reaction of decomposition is decomposition in the presence of sunlight. So there are two decomposition reaction in the presence of sunlight. The one is when aluminum chloride, the solid aluminum chloride is exposed to sunlight, it decomposed into silver and chlorine gas. Same with when silver bromide exposed to sunlight, it will decompose into silver and bromide. Sorry, when silver chloride.
सॉरी चूक झालेलं आहे सारखं सांगतोय पॉज घे करेक्ट वाचून घे करेक्ट कर थांबू ना जरा जिथे सॉरी म्हटलंय त्याच्या 2 सेंटेन्स मागे जा आणि परत सुरू कर
नहीं मैं डिकम्पोजिशन ऑफ ये परत शुरू करते लाइट वाला
तुला जे करायचं ते
ठीक है फोटोलाइसिस so the third and the last decomposition is photolysis. That means the decomposition taking place with the help of sunlight. Here we have two equations where silver chloride is decomposed into silver and chlorine gas is released. In the second, silver bromide, where silver bromide is decomposed, silver and bromine gas is released, Br2. Clear? Here we have to write sunlight. In chemical reaction, whatever is the catalyst or whatever is the temperature, the pressure, everything you have to write on the top of the arrow or below the arrow. So this is all in presence of sunlight. So you have to write sunlight here. Now just see whether the equation is balanced or not. Okay. So let's see AgCl. Ag is 1, Cl is 2 here only 1, so we will put 2 in front of it. Now Ag has become 2, so I'll put 2 in front of Ag. Clear? Here also the same thing we have to do, 2 Ag, and this type of reaction were used in black and white photography. Now because we don't use black and white photography, so it is not that in use. Now let's take the next reaction, that is displacement reaction. Okay. Now in case of displacement reaction, we have two type of displacement reaction, single displacement reaction and double displacement reaction. Before we do the single displacement reaction, we should know about the reactivity series of metal. Okay. Simple mnemonic to learn this series, right? So it is just, it's like काशीनाथ का माली आलू जरा फीका पकाता है. I am repeating it one more time. K Kashi, N-A Nath, C-A Ka, M Mali, A-L Alu, Z-N Zara, and Fika, P Pakata, है. Let's see the mnemonic here. K Kashi, N-A Nath, C-A Ka, M-A Mali, Palu, Z Zara, F Fika, P Pakata, H है. And then let's do the other part. Okay, I have repeated this H here. So this is high court, AAP aap ka. For ka, you don't have to write anything. Okay, just high court, aap ka. Now this CU copper. This is AG silver, AU gold, and PT platinum. Okay, so high court, aap, AAP aap, and ka you don't have to write. So this is a simple mnemonic with which you can learn the reactivity series. In the reactivity series, K is the most reactive, potassium is the most reactive element, then sodium, calcium, magnesium, and here it goes, right? So in this case, the reactivity series goes like this. So from higher to the lower. So platinum is the lowest reactive metal, where potassium is the highest reactive metal. So we are going in a descending order. Now let's do the reactions with this. The reaction which is given in your book with the experiment, it is copper sulfate, CuSO4. It is a blue color solution. Okay, so when you dip iron nails in a copper sulfate solution, what happened? Because in the reactivity series we saw that iron is more reactive than copper. That's why copper was coming under the H high coat, right? So copper is less reactive than iron. So in this case, copper will be replaced by iron. Okay, so you will get FeSO4 plus copper metal. Now this copper metal, when you do the reaction, after some time you will see that this copper metal will get deposited on iron nail. Okay, so iron nail become brown because of the deposition of copper. Clear? Now let's see the let's do the balancing of the equation. It is balance equation, right? Okay, zinc plus copper sulfate. Okay, because zinc is more reactive than copper, so copper will be replaced by zinc. So in a single displacement reaction, we have seen that the less reactive metal is replaced by the more reactive metal. So you will get ZnSO4 solution plus copper. Clear? Okay, the next reaction in the book is lead plus copper chloride. Lead plus copper chloride. In this case, lead is more reactive than copper, so copper will be replaced by lead. What you will get is PbCl2 plus Cu. Again, PbCl2 plus Cu. This is a balanced reaction. Is it a balanced reaction? CuCl2, copper chloride. So it is a balanced reaction. Yeah. So let's do the next reaction, that is double displacement reaction. In the double displacement reaction, as we have already seen that there will be a change in radicals between the reactant. There will be a change in radicals between the reactants. So let's do. Okay, if A is positive here, B is negative, C is positive here, D is negative. A and C, they are metal, and B and D, they are radicals. Okay, now A was associated with B, but in double displacement reaction, A will, when these two salts react together, there will be a change in radicals. So now A will be associated with D. So A, D, A plus, D negative plus. Now B will be associated with C. Will get combined with C. So C plus, B negative. Remember, when you write these type of formulas, compounds, you have to write first the metal and then radical. Metal will come first and radical will come next. Okay, NaCl2. It won't be Cl2Na. Clear? Okay. Now in a double displacement reaction, in your book they have given in sodium sulfate, when you add barium chloride in a test tube where you have barium chloride and you are adding sodium sulfate, you can do vice versa also. What you will get? You will get a precipitate of barium sulfate. I remember that in my session I told you the displacement reaction are of two types. Okay, in the double displacement reaction, there are two type of double displacement reaction. One is precipitate reaction, where the precipitate will form when the two salts react. The other one is neutralization reaction, when the acid is mixed with base, okay, alkali. Okay, when acid and alkali mix together, they give you salt plus water. That is a neutralization reaction. Both are the examples of double displacement reaction. Now let's take the reaction. Okay, sodium sulfate, Na2SO4 plus barium chloride, BaCl2. Okay, now here sodium was initially associated with sulfate. After the reaction, you will get NaCl. Clear? And barium will now associate with sulfate. So BaSO4. BaSO4 will form a precipitate. We either show a precipitate with a downward arrow, or you can just write PPT. So both the case are okay. Let me write this. Now let's see whether the equation is balanced or not. Okay, so sodium sulfate plus barium chloride gives NaCl plus BaSO4. Here sodium is 2, whereas here it is 1. So let's write 2 in front of NaCl, right? Sodium now got 2, chlorine is 2 here, chlorine also 2 here, barium 1, okay, sulfate S single here, single, sulfur is balanced and oxygen is also balanced. Now the equation is balanced. Okay, now let's take the next part of the reaction. The next is oxidation and reduction reaction, which is also known as redox reaction. So redox word itself is made up of two. It is a combination of two reactions, or the two words, which is oxidation and reduction, or reduction and oxidation, right? So what we did in oxidation and reduction reaction, first, what is oxidation and what is reduction? In your syllabus. It is very simple. Okay, oxidation, this is taking place in presence of oxygen. You remember the very first reaction, Mg plus O2. Okay, magnesium ribbon was burned in air. So what happened over there? Oxygen got added, okay, combined with magnesium. So oxidation is nothing but addition of oxygen. So this is addition of oxygen, whereas this is just opposite. Okay, you can write removal of oxygen. Clear? Here removal of hydrogen. When an oxidation, hydrogen is removed, the reduction will be just opposite, addition of hydrogen. Yeah. One more thing which is not there in your book, in oxidation, because hydrogen is removed, so there will also be a loss of electrons, and here because hydrogen is added, there can be addition of electrons. Clear? So but you don't have this in your syllabus. So let's see the reactions which we have in our book. The first reaction, where the copper is heated, in presence of air. So what will happen when you heat copper in presence of air? C plus O2, you will get copper oxide. So children, now we are going to do redox reaction. I discussed about the oxidation and the reduction. Now on the basis of oxidation and reduction, the redox reaction is formed because it is a combination of reduction and oxidation reaction. So in your book they have given, you have to take a china dish where you have to put copper crystals and you have to heat it. When you heat copper crystal, what will happen? Copper is a metal and they react with air, which is react with oxygen which is present in air, and copper oxide will be formed. Okay, and when you pass hydrogen on this hot copper oxide, what will happen? Okay, first let's balance the equation. O2 copper, so you add 2 over here because oxygen is 2, right? Then 2 over here. Now this reaction is balanced. Now when I'll write heat. You can either write heat or you can just put a sign of a triangle which is nothing but delta, and delta represents heat. Okay. Now here when you pass hydrogen over C copper oxide, when hydrogen is passed over copper oxide, then hydrogen will react with copper, and again it is a heat reaction, still supplying heat to it. So what will happen? Copper metal will be formed and H2O will be formed also. So this is what is a reaction. Now if I see in this particular reaction what is happening, CuO, this is copper oxide. Okay, after the reaction it has lost oxygen. Okay, so removal of oxygen, or let's say loss of oxygen, is what? Reduction reaction. So this one is reduction. Okay, this one is reduction reaction. Okay, now when a copper is losing oxygen, who is getting oxygen? Here hydrogen will be getting oxygen. So hydrogen is gaining oxygen. So addition of oxygen is oxidation reaction. Clear? So I'll write oxidation reaction. Now I want to tell you one more thing. Who is a oxidizing agent here and who is a reducing agent here? Because copper is giving oxygen to hydrogen. So definitely copper is a oxidizing agent, right? And because hydrogen, when accept oxygen from copper, it is helping copper to get reduced. So hydrogen is a reducing agent. So this oxidizing and reducing agent, you just have to concentrate on the reactant side. Don't look at the product side. Oxidizing and reducing agent will be here. Okay, so one which is giving out oxygen is oxidizing the other reactant. So this is oxidizing agent. Once you get oxidizing agent, the other will definitely be a reducing agent. So here we have completed this equation. There are two more equations left and we are done with the chapter, revision of the chapter. Let's do the other two equations fast. Zinc oxide plus carbon gives zinc plus carbon monoxide. Here. Now here, as we can see, zinc is losing oxygen. Zinc oxide is losing oxygen. Okay. So we are getting zinc here. So loss of oxygen is reduction. So you are going to write reduction here. Okay. Now who is getting oxygen? Carbon is getting oxygen. So carbon, addition of oxygen is oxidation. Oxidation. Because zinc is giving oxygen to carbon, so zinc is oxidizing agent. Okay, and because of carbon, zinc is losing oxygen, so carbon is a reducing agent. Now let's do the last equation of our this chapter. MnO4 plus HCl gives MnCl2 plus H2O plus chlorine gas. Okay. So we need to balance the equation first over here. So oxygen is 4 whereas oxygen is 1 over here. Here, if I put 4 here, my oxygen will get 4. What about the hydrogen? Hydrogen is will 4 into 2 8. So over here hydrogen is chlorine hydrogen, yeah. So over here hydrogen is 4, chlorine is 4, oxygen is 4. Sorry. Fine. So now the equation is balanced. MnO4 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Fine. Now MnO, what is happening to MnO4? MnO4 is losing oxygen and it is becoming MnCl2. So here losing of oxygen is what? Reduction. So this is a reduction reaction. Okay. Whereas HCl is becoming Cl2. And what is losing of hydrogen? The loss of hydrogen is also known as oxidation, right? So HCl is getting oxidized. So this is oxidation reaction. So we have seen in these equations that oxidation and reduction reaction taking place simultaneously. So these type of reactions are a redox reaction. The other two topic in your book is corrosion and rancidity. I have discussed about corrosion and rancidity in my last lecture. So this is all about the equation in this lecture, and we have finished this chapter. Practice all the equation. Thank you so much.